Okay, so this is our next video for Math 1560 Calculus 1 at U of L for fall 2017. And we're going to move on now to section 3.3, and we're going to look at increasing and decreasing functions. Okay, so what does it mean to say that a function is increasing? So an increasing function is a function where if you choose any 2 points in an interval, say x1 and x2, whenever the x value gets bigger, the function value gets bigger, right? So if x1 is less than x2, then f of x1 is less than f of x2. So making x bigger makes f of x bigger. So as x goes up, y goes up, right? So graphically, you're looking at a graph that goes like this. It's always going up. On the other hand, a decreasing function is one where the graph is always going down, right? The rate at which it goes up or down might change, but it's always headed sort of downwards, right? So for a decreasing function, as x increases, y decreases. So as x gets bigger, f of x gets smaller, okay? So this is what it means for a function to be either increasing or decreasing. So we want to tie this property of increase and decrease, we want to tie this in to the derivative and see what the derivative has to do with increasing and decreasing functions. So what does the derivative tell us? Well, if we have a differentiable function, then the value of the derivative tells us about the behavior of the function. So in particular, whenever the derivative is positive, we know that we're looking at an increasing function. Whenever the derivative is negative, we know we're looking at a decreasing function. We also saw in the last video, one of the examples we did in the video on the mean value theorem was to show that whenever the derivative is 0, we know that our function has to be constant, right? And so those are really the only possibilities for the derivative. It has to be either positive, negative, or 0, and in each case, we can tell what's going on. And notice that in the case of 0, we're not saying that it just happens to be 0 at one point, and then, so this is not the situation where it's positive at one point, and then it's 0, and then it switches to negative or becomes positive again. We're talking about a situation where it remains positive for all values of x. And the way that we see how this result works is, well, if so let's kind of look at each situation, and in particular, let's look at, let's choose, say, points x1 less than x2, 2 points in a B. Okay? And so the mean value theorem tells us that, well, if we've got a differentiable function, right, if it's differentiable, then it's also continuous. And so the mean value theorem says that if we looked at f of x2 minus f of x1, okay, well, we know that we can write that, so the mean value theorem says this, right, that f of x2 minus f of x1 over x2 minus x1 is equal to f prime of c for some number c between x1 and x2. Okay, but we could also rewrite this. We could multiply both sides by the denominator that we see on the left. So if we do that, if we take this denominator and we move it up here, then what we get is that f of x2 minus f of x1 equals f prime of c times x2 minus x1. And we chose x1 to be less than x2, right? So this part here is always positive. Well, now we can see what has to happen if f prime of x is bigger than 0, then f prime of c is bigger than 0, right? So if this is bigger than 0, then we know that f of x2 minus f of x1 is bigger than 0. So we know that f of x1 must be less than f of x2, and we've got a decreasing function. On the other hand, if the derivative is negative, if it's less than 0, well, then it's a negative number times a positive number. So f of x2 minus f of x1 is less than 0. So f of x1 is now bigger than f of x2. And so then we're dealing with a decreasing function, right? So in this case, we're increasing. In this case, we're decreasing. And of course, if the derivative is 0, then f of x1 is equal to f of x2, and we've got a constant function. We're in that scenario that we discussed in the previous video. Okay, so this is really useful. So this property of increasing or decreasing, this is something that you're often interested in with a function, right? You want to know, especially if your function is representing some sort of observable quantity that you're interested in dealing with. Maybe this function, let's say this function gives the value of your bank account on any given day. Well, you want to know whether that function is increasing or decreasing, right? You want to know if it's going up or if it's going down. Well, if you can calculate the derivative, then you can get that information. Okay, here's some technical points. For almost all of you, you can just ignore this slide completely. This is here for those of you who worry about these things like, oh, what about if it's a closed interval? What do we do at the endpoints? What about if what if we're dealing with something like f of x equals x cubed, where if you graph x cubed, right? You have this sort of graph, and so you know that f prime of x, which is 3x squared, is bigger than 0 if x is not 0, but f prime of 0 equals 0. Okay, well, what happens then? Can you still say that the function is always increasing? What about, do you leave out 0? What do you say there? Would you still consider your function to be decreasing at 0, or rather increasing at 0? And you do. Even though there's that one point where the derivative is 0, you would still consider your function to be increasing as you pass through 0. And that's what this point here is talking about. That if you have a finite number, so 1, 2, maybe 10, 20 points where the derivative happens to be 0, but everywhere else the derivative is positive, you would still say the function is increasing. Similarly, if the derivative is negative except for a few points where the derivative is 0, you would still say that the function is decreasing. So if you worry about these kind of borderline issues, these gray areas, this is how you deal with these. If you're not worried about it, ignore this slide and we'll move on to the next one. Okay, so here's a basic example. We've got a function. We want to know where is it increasing, where is it decreasing. So what do? Well, we have our result telling us that the derivative gives us information on these intervals of increase and decrease. So we calculate the derivative, f prime of x. We get 4x cubed minus 16x. 5 is a constant, so the derivative goes to 0. And of course we can factor this, right? We can pull out a 4. We can also pull out an x. That leaves me with x squared minus 4. And then we've got a difference of squares, right? So f prime of x, we get 4x times x minus 2 times x plus 2. Okay, so we can see that there are 3 zeros, right? F prime of x is going to be equal to 0 when x is 0, when it's 2, when it's minus 2. And what do we do now? Well, you probably might be able to guess what's coming. We look for a sign diagram. We want to know where is our function positive and where is it negative. So we draw our number line and we mark off our zeros. Minus 2, 0, 2. And keep in mind this is for the derivative, right? Not for the original function, but for f prime. And then we work out the sign in each of these intervals. And so you guys might have the hang of this by now. Let me just fill out those signs. You can verify that those are the right signs. So it goes plus minus, from right to left. And so now we can use this result about the sign of the derivative telling us whether our function is increasing or decreasing, and we can simply conclude that, well, f prime of x is positive on, well, where is it positive? From -2 to 0, and then from 2 to infinity. So this is where f is increasing. So f is increasing on these intervals, right? From -2 to 0, and from 2 to infinity. And similarly, the derivative is negative on the remaining intervals, and so we can say that f is decreasing on -infinity to -2, and then from 2 to infinity. Okay, and by the way, just coming back to this x cubed example we had a second ago, if you were to look at the sign diagram for this one, right, there's only one 0 at 0, and you've got plus plus on either side, right? So the derivative doesn't change sign as you pass through 0. There is a 0, but it's plus on either side, and so here you would say that f is increasing. Well, it's increasing everywhere from -infinity to infinity, right? Even though there's one point where the derivative is 0, you still consider it to be increasing at that point. Okay, so now in the next video we'll see how to use this information about intervals of increase and decrease to classify our critical points.